We are covering the resultant of 2D and 3D force systems, a fundamental topic in the statics section of the FE civil exam. On the exam, you will be asked to simplify a system of multiple forces and moments into its simplest equivalent form, which is typically a single resultant force, and in some cases, a resultant couple moment. You can find the core equations in the statics section of the NCEES FE reference handbook. For a 2D system, the process begins by summing the components of all forces in the x and y directions. This gives you the components of the resultant force. Rx equals the sum of Fx, and Ry equals the sum of Fy. From there, the magnitude of the resultant, R, is found using the Pythagorean theorem. R equals the square root of Rx squared plus Ry squared. The direction, theta, is found using the inverse tangent of Ry over Rx. A very common exam trap is determining the correct quadrant for this angle. Your calculator will give you a value, but you must look at the signs of Rx and Ry to place the vector in the correct quadrant. For example, a negative Rx and a positive Ry mean the resultant is in the second quadrant. For 3D systems, the logic is the same, but with an added z component. You'll calculate Rz by summing all forces in the z direction. And the resultant magnitude becomes the square root of Rx squared plus Ry squared plus Rz squared. The direction is often described using coordinate direction angles, which you can also find in the handbook. The next critical distinction tested is between concurrent and non-concurrent force systems. Concurrent forces all have lines of action that pass through a single point. For these systems, the resultant is just the force R acting through that same point, and there is no resultant moment about the point of concurrency. However, if the forces are non-concurrent, meaning their lines of action do not intersect at a single point, you will have both a resultant force and a resultant moment. To find the resultant moment about a point, say the origin, you must sum the moments of each individual force about that origin. This is a crucial step in simplifying the system completely. Finally, let's talk about couples. A couple consists of two parallel forces that are equal in magnitude but opposite in direction. The key takeaway for the FE exam is that a couple produces a pure moment, meaning the net force is zero, but it has a non-zero moment. This moment is a free vector, which means you can move it anywhere on the rigid body without changing its external effect. Problems might ask you to find the resultant couple moment of several couples acting on a body, which simply requires you to sum them algebraically. A helpful mental shortcut to remember the angle trap is this phrase: check the signs, find the quadrant. Always check the signs of your Rx and Ry components before finalizing the direction of your resultant force. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.